So I'll one up you. Of course, I haven't seen what they look like. Hold on. I haven't looked in the mirror with them on yet. Kind of hard to see. I just got them. How about that?
Yeah, yeah, you got the look.
All right. Uh, anyways,
I should turn my lights on.
Can everybody see the desktop?
Yep.
Trying to arrange stuff here. Okay. Okay. So, going to talk about futures today. Okay. So I figured out a way to tie. It's going to take a couple of days to do this. It's not going to do it all today, but to tie this example here when we did this polling events and threads. Okay. To tie that with the fork join stuff we did with thread pools. Okay, so we're going to do an example. We're going to build up an example that's going to combine what we did before with what we're doing, what we did with the polling and let's see, just remember these were the examples that would create two children processes, and we would asynchronously read from each. We would asynchronously read from each child, and we did it using threads. And I never did get the polling or the event versions to work in C. Okay, well, we're going to do this example in Java now. But then it turns out that we're going to do this example in Java using essentially something like fork join. Okay, so we're going to use a thread pool to mimic this example. So let's start out by seeing what we need to do, where we should start. Okay, so the other day I mentioned to you what a future is. Okay, a future is roughly the idea. Let me get this set up. Future is roughly the idea that instead of calling a function synchronously, means that you call the function, so you jump into its code, you do the calculation, and you get your answer back when the calculation is done. That's synchronous. You're in sync with the function. So the x waits till the function returns, and then the x gets the value. Okay, rough in that kind of a pseudocode way, what a future is you call this function asynchronously. So you essentially create the future, and it just goes off on its own. It's like a thread. We'll see. It's very much like a thread kind of thing. This future goes off and starts working on calculating this function with this input. And then, but this thing returns immediately. So now x doesn't hold a value yet. X will hold a value in the future. Okay, now you can do one of two things. You could either get the value in x, but that's a way of blocking. When you call get on a future, you're essentially, it should have been wait in a sense. You're going to wait till the value is ready. Okay, so that blocks. On the other hand, you could enter a while loop and do the polling like we talked about in this other example. In this other folder, we talked about polling examples. Okay, here's the polling. You can do it on a future. You can say, while the future is not done, I can do something else. Then I can check about the future again. Is the future not done? But when it is done, then I can get it. But this one, that's why I didn't call it wait, because if you know the future is done and you call get, you will not block. So when you call get, you're really saying, if the future's done, get me the value. If the future's not done, I'll wait. Okay, so you create the future, and then you can get it, which blocks until it's done, or you could ask if the future is done, and if the future is not done, you can go do something else until it is done, and then you can get it. And there's actually one other thing you could do with the future. you can cancel a future. The idea is that if you started several processes and you're really caring about whichever one finishes first, then when the first one's done, you can cancel the others. Okay, so if you've started many futures and one of them finishes and that's good enough for you, you can always cancel a future. So a future has essentially three aspects to its interface. You can get it, you can check if it's done, and you can cancel it. Okay, so here is some code that creates a simple future in Java. Okay, so this example here, simple future example, real simple example of a future. Okay, it's actually not that simple. This is the simplest example I could think of writing with a future, and it's still it's still 100 lines of code. It's 100 lines of code to do something real, okay, simple. So here's what it does. Okay, future is actually, if you look up future in the Java library, it's an interface. Future is an interface, so anything can be a future if it just implements the future interface. To implement the future interface, you've got to provide get, cancel, and is done. And then there's two other methods. You could ask if the future has been canceled. Okay, so the real heart of the interface are the three methods: get, cancel, and is done. And you can also ask, has it been canceled? And then you can also do a get that will block only for a certain amount of time. This will block until until the future is done. That's an infinite block. If you want, you can say get, but only let me wait for 100 milliseconds. If the future is not done in 100 milliseconds, get out of the wait. So only wait for as long as the timeout value is. So this will block for that much time. If the future becomes available, it returns with the future. If the timeout times out, it throws an exception. Okay, so this method, notice it says returns the completed future, but it's a little bit trickier than that. See, if it timed out, it throws an exception. So it's a very flaky kind of interface. You call get with a timeout, and if it gets the value within the timeout, it returns the value. But if the timeout times out, it throws an exception. So then you have to catch the exception to find out that it timed out. Okay, so it's a little bit messy of an interface. Okay, so if I'm going to create my own future, I have to provide these methods. Okay, so I'm going to start working through providing the methods of the future interface. Okay, my future is going to I'm going to create a future that returns an integer. Okay, so future is a generic type. I'm going to create a future that returns an integer. Since I'm creating a future that returns an integer, my future is not going to be generic. I'm just going to call it my future and specifically say that it returns an integer. Okay, so my future is going to have, here's the integer that's going to hold eventually. And my future is going to hold a thread, which is going to actually do the work. The actual work that the future represents is going to be done by a thread. Okay, so here's the constructor for my future. My future will build a thread that runs. Okay, so my future is going to build this thread and start it. So when you create the future object, you essentially launch the calculation. It's a little bit tricky. You're going to need to, after class is over, you have to look this over and run the code and think about it. It's a little bit abstract, but the future is actually really a thread in this case. There are other examples that we can do later on of futures, but in this case, the future is a thread. Okay, like later on, the future could be an I/O operation. It takes a long time to do. That's a much more common example where what the future really does is some real complicated I/O operation that maybe takes several seconds or several minutes to do. Right now, the future just runs a thread. The thread does something real silly. It generates a random number, then it sleeps for that much time, then it returns the amount of time it was sleeping for. Okay, so the thread just does a fake amount of work. Generate a random number between 1 and 10, generate a random number between 1 and 10, sleep for that many seconds, then return the amount of time that it had slept for. Okay, all right, so there's constructing my future. Okay, I don't know how to cancel a thread. So the cancel method, I just left it returning false. Now, in the Java interface, they tell you, I'm sorry, not that one. The cancel interface returns false if the task cannot be canceled, typically because it is already completed. Okay, so I implemented that part. If the thread is no longer alive, which means the thread's finished its work, then you should return false for cancel. So that part I can do. This is how you check if a thread is still running or not. So thread.is alive. If the thread is not alive, then you can't cancel it. Otherwise, I don't know how to cancel it. Okay, I haven't had a chance to figure out. And it doesn't really matter for us. In this example, I don't need to cancel the thread. I really want to see the future work. I don't want to be able to cancel the future. Okay, so I don't really cancel the future. Okay, here's get. Get's supposed to block. Well, it joins the thread. We know how to block. We know how to wait for a thread to be done. You call this thread join. Okay, so get will wait for the thread to be finished. Then when the thread is finished, it returns the result. Okay, right. So when the thread is finished, notice it sets the result field. When the thread is finished its sleeping, it sets the result field. So get does the easy thing. It joins on the thread and then returns the result. Now, what about get with a timeout? Almost the same thing. Join also, see, get with a timeout is going to use join with a timeout. Okay, so I join the thread with a timeout. Okay, then now what? The thing about the join timeout is the join doesn't do something weird. What join does is joins a void function. So if you call join on a thread, if you call it without the timeout, it won't return until the thread is done. If you call it with the timeout, it's either going to return when the thread is done or it's going to return when you timed out. Well, how do I tell which one is that case? So when this thing returns, it could return for two reasons, because the thread completed or because the timeout completed. Well, I can tell if the timeout, which one it is, by calling is alive. If the join finishes, but the thread is alive, that means that I hit the timeout. So I throw the timeout exception. Okay, so because remember, the get was supposed to throw an exception if it hit the timeout. So if I join with the timeout, but join doesn't tell you itself why it finished. It could have finished because the thread finished, or join could return because the timeout timed out. So I have to ask the thread if it's alive, and then if it's alive, that means the join timed out, so I throw a timeout exception. On the other hand, if the thread is dead, that means the thread was really done, so I can return the result. Okay, so there's the get function from the interface. Is canceled, I don't know how to do that. I just return false for that. Is done is easy. It's the same as just is alive. Okay, so the future is done when the thread is not alive. So that's real easy. The future is done when the thread is not alive. Okay, so there's the interface for a future. So I've implemented the future interface, wrapping it around a thread. Okay, and then here's what I can do with it. I can say, create a future object which computes something. Okay, and then I could block until the answer is ready. That's the kind of dumb thing to do. I mean, if you're just going to create a future and block on it, there's really not very much sophisticated thing going on there, but it just shows us the interface. I can create a future and then just block on it, okay? So that's just that's, in this case, it's no different than creating a thread and letting it run, okay? On the other hand, and there's also, I have to catch all these different possible exceptions. When the future returns, I can print the answer. See, the get function returns what the future computed. So future.get returns my answer, and I can print it out. Here's a little bit more interesting thing. Here's a while loop that polls the future. Now, in here, if I wanted to, I could do something interesting. But I don't have anything really interesting to do. But while I'm polling to see if the future is done, if it's not done, I could go like check some other future. I could do anything I want. The idea is that I could ask, is the future done? If it's not, do something else. Then go back and ask if the future is done. If it's not done, do something else. Usually it might be check some other futures. Then when the future is done, I can get its value. I can ask the future for its result. Notice I'm not using get here. I'm just going ahead and getting the result field out of the future because I know that the future is done. Okay. All right. So the future the future here represents a result that I could wait for, which is a lot like a thread. And in this case, I've just wrapped the future around a thread. But later, as we do more examples, we'll see that you don't have to wrap a future around a thread. The future can represent anything that takes a while to compute. Okay. And maybe I should, well, maybe we can do an example in a minute where this future will involve reading a file. Okay. Now I can compile this. And if I run it, what it's really doing is it's doing two futures in a row. Okay. So it's creating this future, and it's waiting for it to be done, then printing its answer, then it's creating a second future, waiting it's for done. Now, each future really just computes for a random number of seconds, then prints out its answer. So when you run it, it looks like this. So I run it 1001, 1002, 1003, 1004, 1005, 1006, 1000. Okay, so it ran for 7 seconds, and then now the second future is going to run for, if you count, it's pretty accurate. Like that, the second future ran for 8 seconds. Okay, run it again. Okay, the first future ran for 9 seconds. The second future ran for 8 seconds. Okay, so the first future, I'm just blocking on it. Okay, so if you're blocked on the future, you can't do anything else. So that's actually not the most interesting idea. The more interesting idea is to poll the future to ask if the future is done, so that you could be doing something else while you're waiting for the future. Okay. Now let's look at another example. It's common enough to wrap a future around a thread. There's even a version of future specifically for this purpose. There is something called Runnable Future. Okay, Runnable Future is sort of a future specifically designed to be wrapped around a thread. So I modified this example to do a Runnable Future. It's not much different. Oops.
Oh boy.
Okay, let me open those two. Okay. Okay, here's the one we did, the regular future, and then here's the Runnable Future. Notice here that I created the thread using an anonymous inner class. Okay, so there's the anonymous, well, this is an anonymous inner class, and here is the run method inside of the anonymous inner class. So remember, a thread is something that just implements an interface. A thread is something that implements the runnable interface. Okay. A runnable future takes the usual interface of a future and adds the run method to it. So for the runnable future, I take this run method and just make it a method in the future. Okay, so I pull this run method verbatim out of this guy and put it in here. Then when I want to create my thread, I say new thread this, because now the future itself is a runnable object. Okay, so the future is runnable, so I can just I can wrap a thread around the future. So this makes it explicit that I'm wrapping a thread around the future, the runnable future. So it's, I mean, notice that there's exact same number of lines of code here. It's six, it's a little bit nice to be able to do it this way, to be able to explicitly say that I'm doing a runnable future, so that my future is going to, my future is the thing that that the thread can be wrapped around. The thread can be wrapped right around, directly around my future. Okay, so other than that, everything else is exactly the same. Okay, so the rest of the interface for the rest of the code is going to be exactly the same. Okay, everything's exactly the same until you get to the main method, and the only thing that's different in the main method is a little bit how I call them. I mean, I will call this a runnable future instead of calling it a future. I still do the same thing. I still call get on it to block, and I call is done on it if I want to poll it. Okay, so actually the only difference in the main method is to use the word future here and runnable future here, because I created a runnable future. So the interface is exactly the same. So this code's the same here. And again, the only slight difference was that instead of having to create an anonymous inner class to implement thread with the run method inside the anonymous inner class, the future itself is the runnable thing. The future itself is the runnable thing, so I can create the thread with this. Okay, and then this one works exactly the same way. If you run it, 1, 2, if 4-second, the first thread, the first future was a 4-second job, and the second future was a 5-second job. Okay. Okay. Okay, let's actually change this a little. Let's actually make this something a little bit odd. I just like, let's do this instead of having the future sleep. Let's have the future just read a character from standard in, and so that'll block it. So let's just do something really dumb. Okay. Scanner equals new scanner system dot in. Okay. Okay. And I need to import scanner. Is
I
it
think you
Java?
need to capitalize scanner after new too.
Did I forget which one? Oh yeah. And I think it's java.util.scanner, if I remember right. Okay. Now, what's my run method do? Well, it just blocks.
I think that's IO scanner, not util.
Oh, well, let's see. Let's compile.
No, I guess it's in util.
Yeah, but what did I do wrong?
S is small, I think. Util.scanner.
Pardon me?
Import java.util.scanner. S is small, I think. In the 6th line. The package name S is small, I think.
Oh, no. Well, I know it's a scanner class in the util. Okay, let's just Google it.
Right.
Java 9 scanner.
No, it's in util.
Yeah, the scanner class is java.util scanner. Okay, now let's see.
Sorry, my bad.
What's,
It just throws IO type exceptions.
oh,
rather than
is that
util
what,
type
I didn't read
exceptions.
the error message carefully now. Is that what I'm missing? No, get next. Oh, no, it's next. It's, yeah, they did something dumb in scanner.
Yeah, a lot of the different
Yeah,
like
you don't say
stream
get, you
reading
just say,
classes, they
yeah,
use different verbiage.
yes, and it's not get next, it's just next. That just gets the next token.
Yeah, it's
Okay.
best not to assume what it is. Just go to the Java docs and
Yeah.
look.
And then, well, actually, to make my, I need to do, no, my runnable object's supposed to run an int, so I should make this result equal scanner.next int. Okay. Because I decided that this guy is supposed to be returning int result. So I'll say result equals scanner.next int. Okay, right? So now I got a future object that waits for somebody at the console window to type a character. So let's try this. So run it. Okay, it's just blocked. Okay, nothing's happening. If I type an integer, hit enter, it returns it. Okay, and now it's just, now the other future is polling. Now that future was just blocked until I typed an input. Now I've got a future that's polling. Okay, and it's waiting for me to do something. When I type 23, it's done. Now, if we want to see that this thing's really doing polling, we could do something dumb here. We could do system.out.print. Okay. Okay. Now what happens when you run this? Okay. Now they're blocked until I type an input. Now see it's polling, but if I type some input, it was doing something until I typed the input. Now notice that I've now got a form of asynchronous I/O. If if you're printing to the output, how can normally how could you print and read at the same time? Think of it. How would you write a simple little Java program that printed something? Now, what it would have to do is, well, you think it'd be really hard to, because every time you call read, it blocks. See, normally in Java, when you call where next int, you're dead, you're blocked. So unless you use some sort of threads and multiple behavior, how can you be printing at the same time you're reading? Well, now we've done it using a future. Okay, the future is waiting for the input. Until somebody taps some input, we just go ahead and print out stuff on our console window, and the console window, okay, this one's the blocked one, so it's really not, now there's no possibility that I could do anything until I type some input. But now my program's busily calculating away until I decide to type some input. Okay, so I'll type some input, and then I hit enter, and when I hit enter, it got the input. Okay, and then at that point, the future was done, so it stopped printing anything out. Okay, and then it printed out the result from the future. Okay, so I've got a system now where I can do a little baby form of I can be reading from standard in while I'm printing to standard out in a kind of a simple way, more or less simple way. It took 100 lines of code. You could, Andrew. Mm-hmm.
I do have an example prepared that's half that, but it does
What?
it in that's half that. It's a lot simpler.
In what sense?
It's 50 lines of code.
Oh, you mean? Oh, well, I could probably. I like. Do you use my brace style, or do you use the?
I
Which
use
brace?
an inline braced. No,
Okay,
I do
well,
not use that. No, I used an inline braced style.
okay, yeah, like right now, like if I started cleaning this up a little bit, like look how many I kind of like
So
those
like I
brace.
write like that, but if it's like a one line thing, like in your try catch,
Mm-hmm.
I put the braces and the I'm a line of code in
Yeah.
the same line.
Yeah, this could
But
probably be
other than that, no.
yeah,
No,
this could
it's
probably be
just a,
shortened about 80 lines of code, 80 or 90 lines of code. Well, what did you do that's fundamentally shorter?
I used an executor service.
Oh, yeah, well, that's what we're going to build up to. See, we're using thread. See, right, that's a different, fundamentally different idea than what I'm doing here. And that's what I want to build up to, is that I want to eventually get away from threads here. See, we want to eventually get to something like what fork join does using a thread pool.
Yeah.
So executor service is synonymous with what people call a thread pool. Okay. So
Yeah.
we really want to, we want to get to that point, because this is okay in some situations, but there are better ways to do this. Okay. But the future itself doesn't care whether it's the future itself doesn't care whether it's wrapped around a thread or if it's put in a thread pool. That's what we're going to do. We're going to switch from a future that's wrapped around a thread to a future that's placed into a thread pool. Okay, and that's what I want to build up to.
I didn't do that either, actually. So I didn't write a future. What I did was I made a runnable
Yeah.
and handed that to an executor service.
Yeah. And you could, there's a bunch of different ways to do this. If you go over here to the future interface,
It's a bit of a rabbit hole.
well, you see, for example, see there's future tasks. Future tasks exactly are meant to be put into task pools, thread pools. So some people put runnable objects in their task pools. Some people put future objects in their task pools. There's a couple different ways to do this. So we're going to look at a variety of different ways to accomplish these different things. So what you did was one of them, and that's what we're going to build up to that one and some other ones too. Okay, and kind of what we want to do is build up a vocabulary of different ways to do these things. Instead, to look at how Java designed the library to not say do it this way. Java designed the library to say you can do it a whole bunch of different ways. Sometimes that's good, sometimes that's bad, but actually Java has a pretty good reason for being able to let you do it a lot of different ways. The different ways have their advantages and disadvantages. So right now, yeah, I'm building futures, and I'm building futures wrapped around threads. And as we do different ways, like your case, you could just build a runnable object and throw it into the thread pool. Or you could build a future object around a runnable object and put the future object in the thread pool. So there's a variety of ways to do it. Depending on what you want to do, one way might be better than another.
Okay. I was looking for the most succinct and simple thing to do, which seemed to be what I settled with. If
you want to do it with the least amount of code, that's probably the way to do it. But at the same time, sometimes you have to do it with more code because you need a more elaborate structure. So if we learn all the vocabulary, then you know like what to do in the more elaborate case, and you can know what to do in the simplest case. So like here, instead of saying, let me do it in the simplest possible way, I'm just saying, here's how to wrap a future around a thread. Okay, now actually, we've done two things now. We've wrapped a future around a thread and wrapped a future around an IO operation. So we've actually done two kinds of things. Oh no, I'm sorry. Oh, wait a minute.
That's exactly what you did.
I wrapped a future around a thread around an IO operation. So let's see if we can just wrap a future around an IO operation without the thread itself. Okay. No, we can't do that.
Why not?
Because there will be somebody's got to do the work of the future.
I mean,
so we need a thread to do the work of the future. Otherwise, our main thread will do the work of the future, and then we're single threaded and we block on the IO.
I mean, presumably, like if you are IO bound, most of the time is just spent around waiting for a response from either something like a hard drive or a sensor or a network interface.
Yeah, but
as soon as the message shows up, you're done.
No, who is going to call scanner.nextInt?
Hmm.
See, if
The main
I
thread.
huh?
The main thread, presumably.
Yeah, but then I'm single threaded and I cannot do IO. I can't do this example. I can't do this. Remember, I had somebody printing out while somebody else was waiting for the input. That essentially required 2 threads. See, here, this would have required 2 threads because somebody had to be blocked on the input while somebody else was printing out output. So there had to be 2 threads here. Otherwise, if I did this in 1 thread, when I constructed the future, yeah, see, you have to think about where is this next in going to be. If you put it in the constructor of the future, then you're doing the IO before the future is even built. Okay. If you do it in the run of method of the future, if you do a runnable future and you put this in the run method, somebody's got to call the run method. Some thread has to execute the run method. If you execute it in main, then you can't do IO on one thread while you're doing this IO on another thread. So in this case, we need to wrap the thread. We need to wrap the future in a thread inside of the future. When you put it in a thread pool, it's the thread pool that has the thread for you. Okay. Then the extra thread belongs to the thread pool. Here, the extra thread belongs to the future itself. The future carries along his own thread. Okay. So the thread is inside the future. And the way if you do it with a thread pool, then the thread won't be inside the future. The thread will be outside the future. But that's what we have to build up to, is that example. Okay. All right. So we've got a future built around a thread, and we have 2 kinds of activities going on in the thread. In this simple future, the thread is sleeping to make up time. So in this one, the thread sleeps to use up time, and in this one, the thread does an IO operation to use up time. Okay, so they're the same in the sense that they have the work being done in a thread. This one's blocking on IO. This one's blocking on sleep for at least a while until the sleep runs out. Okay, so our future can, and another thing we could do is we could have a third one where the future did some real long calculation. Okay, you could just as easily have this future be something that did a hugely long calculation, like sorting an incredibly big array. So, but we do need it to be inside a thread so that the work of the future is overlapping with the work of our main thread. Because if we only have one thread, we can't do 2 things at once. Okay, so our main thread launches the future, and then, well, in this case, it just waits for the future. That's kind of the dumb thing. This is the one that's a little bit more interesting. Our main thread launches the future, and then our main thread can ask if the future's done, and if it's not done, it can do something, in this case, not very interesting. It just prints out a dot, and then it asks if the future's done, prints out a dot, but it can be working until the future is ready. Okay? Now, what I wanted to do was wrap this in asynchronous IO like we did in the example from a couple weeks ago. Okay. Okay. A couple weeks ago, we did these examples here. Okay, where we created 2. Let's see. I don't have the. Oh, yeah, I do. Oh. Here it is. remember this example. Oh, I forgot to compile the echo program. Okay, so compile echo. Okay, remember, we've got two inputs, we got two pipes going into main. Okay, there's child 1 and child 2. And you can type some input to child 1 and it gets echoed up here, remember? So you type in here and it gets echoed up there. Then if you go over to here, well, remember, right now, if you go over here, nothing happens because this first one, it's the parent is blocked entirely. This is the single-threaded version. The parent's only got one thread, so he can't read from two places at once. So right now, he's reading from this guy. So he's reading from that guy. Then when this guy terminates himself, now the main thread goes and says, now I can read from the other child. So now it's reading from the second child. Okay, so the parent is single-threaded. So the parent's talking to two children, but it can only talk to one of them at a time. Okay, right? So, and then we extended that. Now the question was, how can you have the parent read from two children at once? Now we did this in C. Now we're going to kind of switch to doing the same kind of thing in Java. Okay, we had the parent thread trying to read from two child processes, actually there are two child pipelines. There's a pipeline from this child into the parent. There's a pipeline from this child into the parent. But the parent can only, how can the parent read from two pipes at the same time? If it reads from one pipe, it blocks. So if it's blocked on this pipe, it can't be checking this pipe here. So it's stuck, reading from that pipe. Okay. Then when that pipe closes, then the parent says, okay, that pipe is closed, so now I can go to the other pipe. Okay. Then I wanted to do this three ways back then. One way, okay, this was the single-threaded way. Then I said, well, there should be an event-driven way and a polling way. Well, we just saw how to do polling with futures, but I couldn't get Windows events and polling. The code was just, I ran out of time. It was just too much pain to try to go through the documentation of Windows to get events and polling. But we did it with two threads. We created two threads. We had a thread that read from child 1 and a thread that read from child 2, and that was pretty straightforward, okay? So now here's the two children, and the parent has got two threads, so he could read from child 1 at the same time he's reading from child 2. The parent has actually got two threads, one thread dedicated to each child pipe, okay? All right, so we did this in Windows with C and threads, okay? The parent thread, the parent process has got two threads, one thread reading from one handle and the other thread reading from another handle. So there's two IO handles, and each one of these is a typical blocking read. When this guy reads from that handle, if there's nothing there, this blocks. So it's a blocking read, but it's happening in one thread while this blocking read's happening in another thread. Since there's two threads of execution, we can simultaneously read from two threads. Okay, we want to do the same thing with Java now, using futures. Okay, we want to try to create something like this using futures. I want to have a parent process that reads from two inputs with two children. Trouble is, it's a little bit hard to do this in Java, so let me show you how much I've been able to figure out how to do this. I've been able to do some of this in Java. Okay, all right, so here's a kind of interesting little Java program that creates a parent and a child process. And the parent, now it's just one child process. This is just to start with, okay? This is what the Java code looks like for a Java process. The Java process is going to create this echo process. So this Java program is going to run this C program, and this Java program is going to talk to the C program. The C program standard out will feed into the Java program standard in. So when the Java programmer reads from standard in, he won't be reading from the keyboard, he'll be reading from this guy's, and this guy's standard in will be tied to the keyboard. So we'll have a pipe that goes from the keyboard to the echo program. Then the standard out of the echo program will feed the standard in of the this program, and then this program will give us standard out. Okay, so the code, so we're creating a pipe between a child and a parent. Okay, so here's the, oh, actually I want to switch to this one. Here is the Java function that builds a process. Okay, it's pretty straightforward to use. It's called the process builder class. Okay, the process builder class, you give it a command line and it executes that command line in window. But it's like threads. When you create, you remember how when you create a thread, that just creates a thread object. It doesn't run the thread. You have to start the thread. Same thing's true in Java. They take that metaphor here with processes too. This creates a process object. I have to start it later on. Okay, so the process, when I create the process object, that does not create a process, that just creates a process object. The advantage is it lets me do some manipulation of the process before I actually launch it. Okay, so for example, here I'm going to tell Java to take that process object, redirect its input. Okay, so the process builder is going to redirect its input. So it's going to inherit the child process is going to inherit standard input from the parent process. So the child process is going to have its standard input redirected to be the same as inheriting the parent's process. Kind of, you have to read the documentation to figure out how this stuff works. It's not at all readable code. Okay, so, but this creates a process and then redirects its standard input to be so the parent's standard input's now going into the child. Then it launches the child. Now the child's running. Okay, now I do some more manipulation. Okay, notice that the process is called, notice that this is a process builder object. When I start the process, I get another object called a process object. A process builder object is an object that represents an unrun process. A process object represents a running process. Okay? On the process builder object, I do the I/O redirection. On the process object, I can do some more I/O manipulations. Okay? What I'm going to do here is I'm going to, on this Java process, I'm going to set its standard input to be get an input stream from the running process.
So we can print to the processes.
No, it's the opposite. When I get an input stream, I'm reading the output of the child process. See, remember, we've seen this before. When you connect the output of something to the input of something, what do you want to emphasize? Whose output it is or whose input it is? So get input stream is getting an input to the parent process. So it's getting the output stream of the child process and sending it to the input stream of the parent process. Okay? And if you go read the Java documentation, so here's the process, let's see, I want the process class. Here's the process class I call get input stream. Returns the input stream connected to the normal output of the process. Now you got to read that a bunch of times to figure out exactly what that's saying, because it gets confusing as all heck. Okay, so it returns an input stream to the parent process that's connected to the output stream of the child process. Okay. So, there's a little bit of blank to fill in. Returns to the parent process an input stream connected to the normal output of the child process. Okay. All right. So you call get input stream to get an output stream from the child. Okay. So now the child's output is being fed into the standard in of the parent. Okay. Now I wrap a scanner around the standard in to make it a little bit easier to use. Okay. Then when I call scanner.hasNext, I'm asking, has the child sent me some data? So this is asking, has the child sent me some data? If this returns, then the child has sent some data. So I read the data from the child. To make it so that I'm sure I'm actually doing what I want to do, I filter out the vowels. That's just to make sure that we can see that the parent really did something. Because earlier I goofed this up and I actually didn't know, I was just echoing input to output, and I didn't realize that the child was echoing his own output. And it took me a while to get the code working. And then I realized I need to make sure that I'm really, when I print out output from the parent, I have to do something to it to make sure that it's not the child who's echoing his own output. I want to really make sure that the parent read the output from the child. Okay, so if I compile this and run it, now notice, here's, first of all, this is not good. I've actually got two processes running. Call up Task Manager. Where is it? What happened? Oh, there it is. Okay, there's the echo process. See, I launched the echo. Now, if I close this, echo goes away. See, the echo process is gone. So the echo process is being launched by actually this line here. This line here is launching echo. So if I run this program again, there's echo. Okay, now echo, then my Java process is running down here. So echo is reading from standard input on this box, and the Java process is writing to standard output on this box. What I cannot do is get these to be separate boxes like I could do in the C programs. This should be one box for echo, and there should be a different box for Java. And I have not been able to figure out how to do that. Now, if I type in here, okay, so there's some input. Then I hit enter. The output, echo read that input. Echo sent it to the Java program. The Java program read the input from the echo program, and the Java program filtered out those characters. Okay, so the parent process is echoing, is filtering out the vowels from whatever the child process sends it. Okay, then if I type Control Z, now watch, when I type Control Z, the Java program, well, let's see. The echo program terminated. And the Java program terminated also. If I wanted to, let me do something that'll make the Java program well, let's see. Okay, so there's a little message from the parent when, okay. So now if I type some input, it's getting echoed. Okay, if I type Control Z, when I type Control Z, echo will end. Echo ended. The parent process typed that child ended. I could actually, to make you see that the child process, I know what I could do. Make the parent sleep for a little while. Just okay, make the parent sleep, and I have to catch. No, catch. Let's see. Oh, I forgot even the syntax for catching an exception now. Let's see. It was in.
Exception. I usually just do E.
Was it? But it's catch. Is it it's parentheses? It's
Yeah,
Parentheses.
parentheses.
Yeah.
Exception. And then E.
E.
Yep.
Close parentheses. Then brace. And I need. Is that it?
I think
No,
you
that's
need
not
a brace. You need a brace before the catch to end the try, and then put one right after the catch, and still have exception E in parentheses,
Oh, okay.
like kind of like an if thing.
Let me,
Like do you have the closing brace for try? I can't see.
yeah, I can't. Let me. Okay. Oop.
Oh yeah, you've got it there.
Yeah. So catch. Exception E. Boy, I'm drawing a blank on this. Catch exception E.
Wait, I can't.
Then I'm just not going to do anything with the exception. So I put an empty pair of braces here. There. Okay. So now what's going to happen is, oh, and let me actually do another print line. Okay. Okay, now run it. Okay. Now we see there's the child process echo. There's the parent process is the Java virtual running in the Java virtual machine. Okay. Type some input here. Gets echoed. Hit Control Z. The child ended. The Java virtual machine still running for a little while. It's going to run for 5 seconds. Then the Java virtual machine terminated. Okay. All right. So we see that the Java virtual machine and the child were communicating with each other, and they were separate processes. Okay. All right. Now, it would be nice to get them running in separate windows. I haven't been able to get that working. Okay. Now, the next thing to do is, got a few more minutes, to set that up as two piped children. Okay. I want now there to be two piped children. So I want the parent and two children. There'll be both instances of echo. There'll be two children. Okay. The code starts getting a little, well, first of all, just run it and then we'll look at the code. So compile it, run it. Okay. Now there's actually 3 processes running here. I cannot get there to be enough. I don't know if I can get Java to set up the windows. There's the two children echoes, and there's the parent process, the Java virtual machine.
What you can do is you can set up the echo programs as calls from a command prompt. So
It didn't work. Didn't work.
Really?
I did. Yeah, because see, look, I even have that in here. See, that's this commented out line. The IO redirection got messed up. You can, yeah, see, command, start, echo, the IO redirection got all screwed up that way.
Because I had the same thing that I wanted to do in my implementation of that, but in Bash and C, and that's exactly what I did.
Yeah,
I
but
would
Bash and
call
C,
another terminal with the
yeah,
echo
but
program.
Bash and C aren't Java. Unfortunately, I mean, I did that first, and I couldn't figure out what was wrong, and then I realized that if I did this without the CMD, the I/O redirection worked properly. When I did this, the I/O redirection didn't work properly.
Maybe Windows just isn't giving you a
I think it's Java.
input stream to CMD.
Yeah, I think it's Java that's not giving it to me. But whatever.
Mm,
But what? But yeah, I'll keep playing around with it. But that created a separate window. But then I did not have a connection to that separate window. Unfortunately, I lost the connection to the separate window. Okay, so okay, let's see what we have so far. We have 3 processes running. There are 2 childs, and okay, now this code is still single. Sorry. This code is actually still single threaded. So what it does is it's like the single threaded one in C. It reads from one child, then when that child's done, it reads from the other child. So it's not trying to be multi-threaded yet. So it's reading from one of the children until that child closes, then it's reading from the other child. So if you go over here, here's what happens. You type a little bit in, okay? Now, that's child 1. Now, that's child 2. What's happening is there's not 2 windows, so this single window is both children, and they're alternating on who gets the stream. So now when I hit enter, there's no echo because the parent's not listening to child 2 yet. So now that just got buffered in child 2's input stream, but the parent didn't notice it yet. Now this one, that one goes to child 1 and gets echoed. Now this one, it goes to child 2 and doesn't get echoed because the parent's not listening to child 2 yet. Now this one goes to child 1 and gets filtered. Now I'm going to do Control Z. Now you'll see that one of the echoes dies at this point. Okay, I lost child 1. Okay. Now if I type here, now it's child 2 doing the echoing. See, now child 2 is being paid attention to. Okay, so now child 2. Now if I do Control Z again, now the other child's going to die, and the parent dies with it. Okay, and notice I got some stuff that got caught in buffers. There's some weird buffering going on. See, these guys, they were up here. See that WEEB? He appeared down here. And this 3333, it appeared finally down here. The buffering is kind of weirdly happening. I don't really understand why the buffering came out at the end. Okay. Okay. So we have a single threaded parent doing I/O from 2 children. Okay. We have a single threaded parent doing I/O from 2 children. So we essentially have the equivalent of this program here in C, of a single threaded parent reading from 2 children, except that we don't have windows for each children. We have only one window for both children. The next stage is to do multi-threaded parent, but I don't want to do it with thread. Well, we're running out of time. So what I'm going to do is I'm going to turn this Java program, I'm going to write it 3 ways. Okay, I'm going to write it one way that creates a thread to read from that child, and another thread to read from that child. But then what I really want to do is create futures, one future reading from this child, one future for reading this child, and use polling to just poll which future has something ready for it. So I'm going to see if I can, I'm going to try to do this with futures, where one future is reading from one child, one future is reading from another child, And instead of having 2 threads, I can have 2 futures. Okay, so we kind of run out of time, but that's, I don't have that written yet. That's the next step, is to combine this program with these future programs. Okay. Now, then what I'm going to do is actually put these children somehow into a, what we're eventually going to do is put these children into some kind of thread pool. And instead of having threads, we're going to have reading from the children be tasks. Okay. So we want to parallelize this, I'm sorry. We want to parallelize this parent reading from 2 children. We want to parallelize the parent reading from 2 children. The easy way to do it is with threads, but we want to do it without threads. We want to see how we can do it with futures. And then and actually, if I can also do it, see if I can get there to be 2 windows here. Okay, see if I can get there to actually be 2 windows, have 1 window for this child and have another window for another child. I don't know if I can get it to do that, but I can at least get it to have 2. The parent is listening to 2 children now. It's just listening to 2 children in one window from one input stream. So it's actually alternating between them. You know, it alternates between child 1, child 2, child 1, child 2, child 1, child 2, which is kind of flaky. But Java's notorious for not having real good integration with the operating system. Because Java is supposed to be this write once, run anywhere programming language, and since operating systems are so different, you know, Java or Windows and Linux don't really look a whole lot alike, Java has trouble dealing with this kind of stuff. Okay, so Java tries to do it with the process builder and it's got the process class and the process builder class. Okay, so but these classes have been problematic for years. They used to be buggy as can be. These classes used to actually just be flat out buggy. I don't think they're buggy anymore, but they're still kind of awkward to use. And I'll see if I can figure out any way to get them to launch new windows, because that would be really nice, where the parent could launch 2 windows, one child running in one window, one child running in another window, and the parent's output being in a 3rd window, like we did with the C program. Okay. The C program does it real nice. Is it still there? Oh, I did. Let's see. Oh. See, you just run this, you know, the idea that you just get one window that represents one child, another window that represents the other child, and then here's the window that represents the parent. That's a very nice, you would hope that Java could, Java should be able to do anything C can do. If C can do this, Java ought to be able to do it, but that doesn't mean it really can, because this is very much talking to the operating system. You know, this code wasn't even written in C. This code was written in Windows. Remember, this code was making lots of use of the Windows system calls. So all that code was based on writing Windows system calls. Yeah. So yeah, it wasn't easy to write this in Windows even. Yeah, it took 200 lines of Windows to get that to get these 3 little windows up here and communicating with each other. So whether or not I can actually get it to work in Java or not, we'll see. Okay. But we do want to get this, try to get the Java asynchronous IO going. Okay. So we want to be able to get combine these examples, see if we can combine the future idea with these reading from multiple children idea to build up the idea of asynchronous IO. Okay, futures is one example of asynchronous IO, and then eventually we'll see how it ties back to the fork join, because can be done in a way that's real similar to the fork join. Okay, all right. Any question? And Andrew, you sent me that code. I'm still looking at it. I hope that I can look at it because I got some ideas. Some of this was copied from there. And I'll get. I'll look. What I want to do is Andrew created this. I'll show you what he. Here's a folder. It's kind of fun. Folder with 58,000 books in it. Okay. And that's actually really neat. The folder is, whoops, I closed it. The folder is, this is big data. Yeah, the folder is.
Windows is gonna chew on that for a few minutes, or not.
20 gigabytes of data, 20 gigabytes of text that you can do all kinds of analysis on. Whatever you want to do with 60,000 books. Okay, 20 gigabytes of data, 60,000 books. So there's a lot of opportunity to do parallelization.
And it's all ASCII plain text,
yeah,
by the way.
Yeah, if you just open one of these, each one of them is a book. Oh, Arthur Conan Doyle, great. Which Sherlock Holmes book is this? The Vital Message. Okay, so that's a Sherlock Holmes novel. Okay, so it's just a huge amount of novels, public domain novels as text files that you can count. People, a lot of times people just do something as simple as count the words in each book. Ask how many times does the word onomatopoeia appear in any of these books. Okay, so you could do all kinds of interesting just to keep your computer busy. The thing is to see how fast you can do things. You've got a lot of opportunity for parallelism here because these are just 60,000 different files, and you can open them and do things on them. So,
if anybody wants to compete, I have a set of tests written out. My time was 30,000 books in 30 hours on a 4-core machine.
To do what with them?
It was a large battery of tests that I've also sent to you.
Okay, yeah. The simplest thing is to do things like just count the frequency of a particular word. How often does the word husband appear in all those books? Yeah, so you could just do word counting. You could do really sophisticated artificial intelligence things on these, but that's not what this class is about. Here, it would just be about just do something dumb, but just do it on a lot of data. Just pick a word, your favorite word, and ask how many times does it appear across all 60,000 of these books. Okay, that would be one thing you could do. Okay, so what we're going to do is build up different ways of doing parallel I/O using futures and thread pools and fork join. Using a combination of futures, thread pools, and fork join, we'll see how we can build up different ways of doing parallel I/O. So, I didn't give you, let's see. Yeah, I should put a reading up here for futures. There are some nice things on the internet, I think, that explain a little bit about the future. You have some examples of future code here, and I think I can come up with some reading for you that will explain a little bit about how to use futures and combine them with threads, thread pools, and I/O. Okay. So look at the code here. Especially, this code here is actually kind of interesting. The way Java communicates, the way Java communicates with the operating system, kind of tricky code. It's actually not a lot of code. It's just that you have to read the documentation to see what order you do these in. Look at that code, read the documentation on process builder and process. If you want, try to write your own programs that just try to get a Java program to launch a Windows program. Get Java to launch Notepad. Get Java to launch some other program. Okay, so I'll go ahead and quit here. Let's see. So I'll go ahead and end the meeting now. All right. Good night. Bye.
Bye.
Good night.
Bye. Good night.